Hi, good morning everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today we are going to discuss about the half-wave rectifier. This topic which comes under the subject circuit analysis and devices. So come, let's get into the topic. The main applications of PN junction diode is in rectification circuits. These circuits are used to describe the conversion of AC signals to DC in the power supplies. Diode rectifier gives an alternating voltage which pulsates in accordance with the time. The filter smooths the pulsation in the voltage and to produce DC voltage. A regulator is used which removes the ripples. There are two primary methods of diode rectification: half wave rectifier and the full wave rectifier. What is half wave rectifier? So in half wave rectifier, one half of each AC input cycles is rectified when the PN junction diode is forward biased. It gives little resistance, and when it is reverse biased, it provides high resistance. During one half cycle, the diode is forward biased when the input voltage is applied, and in the opposite half cycle, it is reverse biased. During the alternative half cycles, the optimum result can be obtained. Working of half-wave rectifier. The half-wave rectifier has both positive and negative cycles. During positive half of the input, the current will flow from positive to negative, which will generate only a positive half cycle of a AC supply. When a AC supply is applied to the transformer, the voltage will be decreasing at the secondary winding of the diode. All the variations in the AC supply will reduce, and we will get the pulsating DC voltage to the load resistor. So this is the input AC voltage, and we have this half-wave rectifier. Half-wave rectifier, we have only one diode, PN junction diode, and one load resistor RL. This has the one transformer, step-down transformer, where the primary, which has number of turns, is higher than the secondary coil turns. So first, this is primary and the secondary winding. So the primary induces the primary and induces to the secondary winding and the current flowing through it. So when the diode is kept on the secondary side, what will happen, as we discussed in the previous slide, only the half cycle, the positive half cycle will be coming out of the SI output, and the negative cycle will be rejected as it is comes under the reverse bias condition. In a second half cycle, the current will flow from negative to positive and the diode will be reverse condition. Thus, at the output side, there will be no current generated and we cannot get power at the load resistance. A small amount of reverse current will flow during reverse bias due to minority carriers. A half-wave rectifier circuit consists of three main components as follows: a diode, transformer, and a resistive load. So given below is the half-wave rectifier diagram. So that we already seen. So here supply, AC supply, and the primary winding and secondary winding, diode is there and load is there. So it's a step-down transformer. So working of a half-wave rectifier. In this section, let us understand how an half-wave rectifier transforms from AC into DC. A high AC voltage is applied to the primary side of the step-down transformer. The obtained secondary low voltage is applied to the diode. The diode is forward biased during the positive half cycle of the AC voltage and the reverse bias during the negative half cycle. The final output voltage waveform is shown in the figure below. So this is the positive AC signal and negative and positive. Only the positive will be allowed. So we have a DC output. This output is called the pulsating DC output as it contains pulse. So this is the half-wave rectifier waveform uh, input and the output waveforms. So here this is the actual input waveform AC signal. So here this pi, 2 pi, 3 pi, 4 pi is nothing but of a frequencies. That's a degree. So that is when you are after the rectification process, the output value will be only 0 to pi, and pi to 2 pi it's a reverse bias, reverse signal, negative signal. So there is no current flowing through the diode. So only this won't be allowed, right? And 2 pi to 3 pi again positive cycle. So positive signal, positive will be allowed. So likewise, we will be having 0 to pi and 2 pi to 3 pi, 4 pi to 5 pi. Likewise, we have a output waveforms after the half wave rectification process. And when it comes to the applications of the half wave rectifier, Here are few common applications of the half-wave rectifiers are they are used for signal demodulation process. They are used for rectification application and used for signal peak applications. And the drawbacks of half-wave rectifiers are power loss, low output voltage. The output contains a lot of ripples. Thank you.